Finishing up lesson 5.2, we looked at what's called end behavior for a polynomial function's graph. So we're looking at what happens to the graph as x goes to positive infinity, which just means to the right, and then as x goes to negative infinity, or to the left. We focus on two things, the degree of a polynomial and then the lead coefficient. So notice in the first row, we have odd degrees here and here. Odd would mean like x to the first power is the degree, x to the third power, x to the fifth power, just an odd number. When you have an odd degree, your arrows will always go in opposite directions. So notice for these two examples drawn in red that the arrows never go in the same direction. One's going up, one's going down. And that's just decided on if the lead coefficient is positive or negative. So think of it kind of like slope of a line. If you have a positive slope from left to right, the line rises. That means on the left side, it falls, and on the right side, it goes up, or it rises. So as x goes to positive infinity, or to the right, oh, wow, never mind. That was a bad way. Wow, my pen's really working weird on here, sorry. As it goes to the right, there we go, this way, notice the arrow points up to the top. So f of x also goes up to positive infinity. As it goes to the left, this way, the arrow points to the bottom, so f of x, or your output, goes to negative infinity. It drops down below, like so. Now the in-between stuff is where kids are having the most kind of questions about this picture. Like, how do you know when it curves? Well, we're going to focus on the y-intercept, but the rest of kind of like those turning points can be up to you. So our goal is just to focus on where the arrows go, and that's using that end behavior with the infinity symbols, and then where the y-intercept is. Eventually we can get more specific, but that's as far as we want to get for these graphs. All right, so when your lead coefficient is negative, like a negative slope, on the left side it points up, but on the right side it points down. So as x goes to the right, the output, or f of x, goes towards negative infinity, down here at the bottom. As x goes to negative infinity, or to the left, the graph will point up. So it's up here. I just put the stars there just to recognize where the arrows are supposed to be when we're done graphing. You don't have to draw the stars on your paper. Now, if a degree is even, think of a parabola. We did a lot of work graphing parabolas in chapter 4, and the arrows always went in the same direction. Either both pointed up or both pointed down. And it just, again, depends on if your lead coefficient is positive or negative. So notice if the lead coefficient is positive, both the arrows end up at the top of the graph. So no matter if x goes to the right or to the left, both of your arrows point up towards positive infinity. In the alternative, if x is negative, if the lead coefficient is negative, then both your arrows point down. All of these examples in red and blue are just kind of sketches of what it could look like. They're not specific shapes for the even versus odd. It's just, this is what it could look like when you're sketching your graph. Down below, we'll look at kind of how to describe and how to determine that end behavior, and then figure out maybe where those turning points and the curves go on the shape. So let's take a look down below. It says given f of x equals 7x to the fourth plus 3x cubed minus 7x squared plus 2x minus 1. Describe the end behavior and sketch what the graph might look like. Well, looking at this function, we recognize that the degree is 4, and that's an even number. So we know both arrows will go in the same direction. The type of functions from the other page, when you have an x to the fourth, that's a quartic function. So the shape is going to look like a W or an M. The lead coefficient is positive, which means both arrows will open up, so that means our shape will definitely look something like a W. The other point that we can find really easily is the y-intercept. The y-intercept is always what happens when x equals 0. Well, if x was 0, all of these terms would just cancel out. So the constant at the end is always the y-intercept. All right, so for end behavior, what was written or what was typed out is like the template that you'll always have on your paper. What's written in blue is what we just have to figure out based on the degree and the lead coefficient. Since it's an even function and it's positive lead coefficient, that would mean both arrows point up. So notice I have positive infinity, positive infinity. Now I plotted the y-intercept. You can see that down here at 0, negative 1. And I know my shape has to look something like a W because I have both arrows at the top. And it's not a quadratic function like a parabola, so it has to have that like loop in there, that kind of curve in the middle somewhere. It's open to interpretation. The only thing you have to have on this graph is it has to cross at 0, -1, and your arrows have to be at the top. For this last example, what we had to recognize was the fact that it wasn't written in standard form. It said given f of x equals 3x squared minus 6x cubed minus 5. Well, recognizing that the degree is the biggest exponent, notice x to the third needs to be written first. We took time to rewrite it in standard form. That way we were clear on what our degree was and our lead coefficient. Because it's a degree 3, that's a cubic function. It's technically not a roller coaster, but it just kind of goes up and down and up, kind of like what you would do on a roller coaster. And with the lead coefficient being negative, that'll help us determine that end behavior. If it's odd, arrows have to go in opposite directions. And if the lead coefficient is negative, it's kind of like a negative slope. So on the right side, it goes towards negative infinity. It's dropping down to the bottom of the graph. On the left side, it goes towards positive infinity. That means it's up over here. Now I noticed the y-intercept was 0, -5 because of that constant at the end, so we plotted that point as well. A cubic function can cross the x-axis up to 3 times because it's a degree of 3. That's another thing that you can tell when you're sketching your graph. It can cross an x-axis up to the number of the degree, but never more than that. So notice I started on that left-hand side and I kind of curved my graph down, made it go up through -5 on the y-axis, and then I went up over the x-axis and dropped it right back down. Again, there's a lot of other points we could put on here, but these are just the ones we're going to focus on. So I hope that was helpful kind of walking you through the notes for 5.2.